Hey guys, Eddie the Magic Monk here. I saw this really cool animation that Google did today to celebrate the mathematician Bull's birthday or something like that. Yep, George Bull's 200th birthday, and a lot of you are probably watching this thinking, what is going on? There is actually a little bit of Boolean algebra involved in this. So my goal today is to help you guys understand this animation by teaching you a little bit of Boolean algebra. Basically helping you guys understand what these logical operators mean. So firstly, let's remind you guys what variables are. Okay, variables are just basically a letter. Okay, a letter that contains some value, some quantity. Now, what you would be used to in normal, ordinary algebra is x would contain a number. So, for example, x could be 3 and y could be 7. These are all real numbers. Okay, and they work with numerical operators. So for example, I can say x plus y equals 10, right? This operator here, the plus sign, is called arithmetic operator. So what's in another arithmetic operator? X times y. 3 times 7, 21. Okay, not very awake right now because it's 10:30. But anyway, so that's plus and that's times, and you can think of minus and divide and all that. Those are arithmetic operators. Today we're going to introduce to you logical operators. And instead of plus and times and minus and divide, which are arithmetic operators, logical operators are and, or, XOR, or not. So these are pretty much the few things that you see in the Google animation that they made. Alright, x and y, x or y, x or y, not x. So let's talk about what they are, the logical operators. So basically, we got two variables. We got x and we have y. Now, x can either be true or false, and y can either be true or false. So if you have a look at the x and y, the two circles that they have in the animation, right? These two circles here, let's say x is true when the letter appears, and y is true when the letter appears. But if the letter is not there, that means x is false, right? So just then x wasn't there, so that would mean x is false. All right, so let's just draw the possible operation. So I have x there and I have nothing here. So that means x is true and y is false because it doesn't exist. Right? Does not exist means false. So now let's talk about what happens when we do x or y. Okay, what does that operator tell us as the answer if I was putting in x or y? If x was true and y is false, then what is the answer? The answer is true. So why is that? The OR operator basically says if either of the operators is true, so if x is true or if y is true, then the answer is true. What about if both of them are true? Yes, the answer is true as well. The only time x or y would return false is when x and y, they're both false, then the answer will be false. So let me write that out in the truth table. So I got x, and I got y, and I got x or y. So if x is true and y is true, then x or y is true. If x is true, y is false, then x or y is true. If x is false, y is true, x or y is true. If they're both false, then x or y is false. So the only time x or y is false is when they're both false. Otherwise, if one of them is true or if both of them is true, then x or y is true. So that's the OR operator, which is a little bit different to real life, because when people say OR, sometimes you think that they mean that only one of them can be true. But in the programming sense or in Boolean algebra, x or y, if both of them are true, then the answer is true as well. Okay, so let's now do AND, x and y. Okay, now if you have a look at the example, okay, x is true right now and y is false. So x and y is actually false. So why is that? Right? If x is true and y is false, x and y is false. So the reason for that is because the AND operator basically is saying that both of these variables have to be true in order for the answer to be true. So the only time x and y is true, so the only time x and y is true is when both of these are true. X is true, y is true, then x and y is true. Otherwise, if one of them is false, then x and y will be false. So if x is false, x and y is false. If y is false, x and y is false. If both of them are false, guess what happens? Also false. So the only time when x and y is true is when both of them are true. Okay, so now let's do the XOR x XOR y. So XOR means exclusive OR, and basically exclusive OR is only true when only one of these variables is true. So if x is true and y is false, then x XOR y is true. Or if x is false and y is true, then x XOR y is true. So only when one of them is true, the answer will be true. If both of them are false, then the answer will be false. And if both of them are true, then the answer will also be false. So it'll only evaluate to true if only one of these variables is true. Alright, so in this case, because only one of them is true, so the answer will be true. So x or y will be true, right? Because only one of these is true right now. Okay, so one more thing. If I say x is true, then not x will just be false, right? The not operator just reverses whatever is inside that variable. So if x was false, then not x will just be true. So with all this explanation, now you should be able to look at this diagram and go, yep, I can see exactly why that's happening. Because, okay, let's have a look at the G. Okay, the G is linked to x and y. So the G letter will only light up, okay, this blue letter will only light up if there is an x and there is an y in both circles, which means that they're both true. If x is true and y is true, they're both true, then the G letter would light up. See, it lights up now. Okay, now the G letter is dark. G letter is dark again because not both of them is true, and so on. So you should be able to use my video to figure out the rest of the animation, but I'm just going to do another one. So x or y, this yellow letter, should only light up if there is at least one letter showing in either of these circles, right? Because X or Y means that either X is true or Y is true, or they're both true. Alright, when there is no letter, so when both circles are dark with no letter visible, then the X or Y will be off. The yellow light will be off. Otherwise, in every other case, the yellow light will be on. Okay, I hope this tutorial helps you to understand more about logical operators and Boolean algebra. Okay, thanks for watching, guys. See you next time.